So here we are with two rational expressions that we're going to add together where our denominators are different. So pulling from what we already know about adding fractions that have different denominators, we're going to use that for here. So the first thing I'm going to do is I'm going to find my lowest common denominator, which in this case is just going to be multiplying the two denominators together. So x plus 2 times x minus 2. I'm going to use that now, that expression, as my common denominator. So x plus 2 and x minus 2. My original fraction is 3x over x plus 2. So that means that if I multiplied my denominator by x minus 2, I also have to multiply my numerator by x minus 2. That way, if I were to cancel both of those out, I would be left with my original fraction. So this is exactly the same process that we used with the regular fraction. We are now using with rational expressions. I'm just going to take the yellow away so that I don't mix our answer up. I'm going to do the same thing with my second fraction. My original fraction is x over x minus 2. I'm going to multiply x minus 2 by x plus 2. And then whatever I multiply my denominator by, I also have to multiply my numerator by. And again, that means that I could cancel my x plus 2's out, and I'd be left with my original fraction. So I know that this and this are equivalent expressions. Just get rid of my yellows. And this is my new expression with my lowest common denominators. Now I can go ahead and I'm just going to make it a little bit smaller. Now I can go ahead and add my numerators over top, wrong color, over top of my lowest common denominator. So I'm going to keep my lowest common denominator as x plus 2, x minus 2, and I'm going to go ahead and combine, trying to clean this up a little bit. I'm going to go ahead and combine my numerators. So that's 3x times x minus 2 plus x times x plus 2. Now I can go ahead and I can simplify my numerator. So to simplify my numerator, I'm going to take 3x and multiply it by x. That's going to give me 3x squared. And then 3x times negative 2 is going to give me negative 6x. Then I'm going to add that to x times x is x squared, and x times positive 2 is positive 2x. Now we're going to go ahead and combine like terms and simplify this numerator. Again, always keeping the denominator as x plus 2, x minus 2. I can now piece out my like terms. So x squared is like, so 3x squared plus x squared is 4x squared. And then minus 6x plus 2x is going to give me minus 4x. Now I'm almost done. My expression is looking much simpler than what it was. It's all combined over a denominator, which is great, but what I'm going to do is look for ways that I can cancel out my factors. So first of all, I can see that my greatest common factor, something that's common to both terms 4x squared and minus 4x, we call that the greatest common factor, is going to be 4x. 4x goes into 4x squared, and it also goes into minus 4x. So keeping my denominators, x plus 2, x minus 2, I can parse out my greatest common denominator 4x. That's going to leave me with x minus 1, like that. Now when I factor out my greatest common factor, unfortunately, you can see that none of these expressions can actually be canceled out. I was hoping that I could maybe cancel a couple out and then that would reduce my expression even further or simplify it even further. But because it can't be simplified any further than this, then that's not going to work. What I need to do now is that I need to get rid of any parentheses in order to get the most simplest form of this fraction. So what I'm going to do is I'm going to FOIL x plus 2 times x minus 2. So that's going to give me x squared minus 2x. 2 times x is positive 2x, and then 2 times negative 2 is negative 4. Negative 2 plus 2x, those cancel out because that's going to be 0. So my new denominator is x squared minus 4. That means that my most simplified expression without parentheses is going to be this. 4x squared minus 4x over x squared minus 4. And that's going to be my final answer. And here is what the whole solution looks like all together. Remember, understanding how to add two fractions with unlike denominators is going to help you when you're working with adding and subtracting rational expressions with unlike denominators. I have another example to show you just to solidify this concept. So this is my last example. Again, I have two rational expressions. My operation is subtracting this time. I can't go ahead and just subtract my numerators because you can see that my denominators are different. And I have a trinomial as my denominator here versus a binomial. So even more messy, more complicated than the last example, but completely doable. Again, watch to see where I use that first procedure about adding fractions with unlike denominators. I'm going to do that here as well. So the first thing we need to do is find the least common denominator. So the least common denominator in this case is going to be our x squared minus 7x plus 12 times our x minus 3. So we're just multiplying the two denominators together. So our next step is to get our equivalent fractions. So our original fraction is 2x plus 3 over x squared minus 7x plus 2. And then we're going to multiply that denominator by x minus 3 to get our common denominator. And whatever we multiply the denominator by, we also have to multiply the numerator by, so that if those two were to be canceled out, we'd be left with our original fraction. So that's the first step. We also need to do this to our other fraction. So we have 2 over x minus 3. We're going to go ahead and multiply that by x squared minus 7x plus 12. So we get our common denominator. And whatever we multiply the denominator by, we also have to multiply the numerator by. So that, again, if we were to cancel those two expressions out, we would be left with our original fraction, which we are. Now that we have two fractions with the same denominators, we can go ahead and simplify the numerator. So our common denominator is going to be this, plus 2 times, sorry, that's 12. There we go. X minus 3 all over. Now what we need to do, before we can subtract this expression, these two expressions, we have to simplify our expression. So using the FOIL method, I'm going to multiply 2x by x. That's going to give me 2x squared 2x times negative 3 is going to give me negative 6x. Positive 3 times x gives me positive 3x, and 3 times negative 3 is going to give me negative 9. So that's my first numerator simplified. Oh, going too far back. There we go. Now what I need to do is I need to simplify this side. So I have negative 2 times 2x gives me negative 2x squared. I have to extend my line. Negative 2 times negative 7x gives me positive 14x. And negative 2 times positive 12 gives me negative 24. So it's very important that when you do combine the numerators that you simplify each of the expressions first before you can bring it all together. Need a little bit more room. Now I'm going to try and simplify the numerator by bringing like terms together. So I'm just going to write down my denominator again. And now I'm going to combine like terms. So I have 2x squared minus 2x squared gives me 0, so those cancel out. Then I have negative 6x plus 3x gives me negative 3x, plus 4x gives me positive 11x. And then lastly, I have negative 9 subtract negative 24 gives me negative 33. Lastly, I can see here that I have a greatest common factor for each term, so 11x and negative 3x both have a greatest common factor in common, which is going to be 11. So I'm going to parse 11 out of this expression. Again, keeping my denominator the same, when I take the greatest common factor of 11 out of the expression, I'm left with x minus 3, because 11 times x is 11x, and 11 times negative 3 is negative 33. By doing this, by taking out that greatest common factor, what you can see is that I can now cancel out my x minus 3 and x minus 3. That greatly simplifies the expression, and my final answer is going to be 11 over x squared minus 7x plus 12. If I need to go further, what I might have done is also found the factors or factorized this polynomial here, but I didn't need to go that far because I was already able to take out the x minus 3's in this case. So my final answer is for this, or the solution for this subtracting rational expressions, is this final answer of 11 over x squared minus 7x plus 12. So I hope you found this video helpful. Just remember that we are just adding on the topic of adding fractions with different denominators. So we're using this idea of a lowest common denominator, and then from there doing much more complex examples involving rational expressions. So thanks for watching. Bye for now.